My name is Fawaaz Ahamed. The title of my project is The Best Structure Type for Building a Bridge. The project is in the physical science category. And my problem statement is what type of structures is the best for building bridges. The hypothesis I came up with was that the bridge built without arches would be weaker because it does not have as much support, and I was right. To summarize my background research,
Fawaz, can I ask a question? You did an arch style bridge, and what was the other one?
the beam bridge.
A beam. Okay, thank you.
I found that both bridges have similar parts such as decks and abutments. I also found that arch bridge tends to be weaker if they don't have sidewalls to support the arch. Sidewalls are what makes the bridge stronger because the sidewall is what keeps the arch in place and allows the pressure on the top of the arch to be evenly used. The materials I used when doing my experiment were Legos, a scale, and weights and books as weight. The steps of my project are as follows. Step 1. Build an arch bridge out of beam and beam bridge out of Legos. Step 2. Gather weights and books to test the bridge's strength. Step 3. Test the strength of each bridge by placing weights on the books on the bridge one by one until it breaks. Step 4. Retest the bridges, change the variables height and number of piers.
So
Step 5.
you retested each bridge.
Yeah.
How many times did you retest?
One.
Okay, good.
Step 5. Write down my observations. The main variables that I was testing was the amount of support a bridge had as compared how much weight it can hold. I was careful to control how long the bridge was and made sure to use the same type of Legos to build each bridge. The amount of piers I had and how much weight, the height of a bridge, amount of piers I had and how much weight the bridge could hold when each variable was changed. I learned that the arch bridge is stronger than the beam bridge. This is because the arch has more support than the weakest point. I also learned that
Fawaz, I'm sorry to interrupt. What is the weakest point?
on the middle,
In the middle of it?
between the piers, like on the middle.
Okay, and did you test different types or styles of arches or beams? So you ran one test with an arch and then repeated it?
Like here's the 3 arches, now 2 arches, and here's the 1 arch, and here's the 2 beam, and here is the 3 beams.
Okay, good. That helps to use the pictures to show. Good job.
I learned that the arch bridge is stronger than the beam bridge. This is because the arch has more support for the weakest point. I also learned that the more piers or the smaller the keystone in the arch, more weight it could hold. I would change the amount of piers and arch I used to test. I would do 4 piers and 3 arches. One of the measured variable was adding extra piers and arches. The control variable was the length and width of the bridge stayed the same. The part I most enjoyed was building the bridges. It was fun figuring out the best way to build each bridge. Now here's my multiple choice questions. What happens when the keystone is longer than arch bridge? A. The bridge is stronger. B. The bridge is weaker. C. It doesn't matter. D. The bridge can be built. But this is the opposite question. Like I told you, like the keystone is bigger when it's smaller. Like the arch bridge will be stronger.
Can you explain the keystone? Where is the keystone?
It's on the middle of the arch.
In the middle of the top of the arch?
Yeah.
Okay.
Should I Should I repeat?
Yes, I see a couple of nods.
A, the bridge is stronger. B, the bridge is weaker. C, it doesn't matter. D, the bridge can be built.
B.
Yeah.
Good. Oh, look at that. Oh, and sweet. It's a healthy treat, a healthy snack right before advisor. Good job, Fawaaz.
Why is the weakest point of the beam bridge the center of the deck between two piers? A, the bridge does not have weakest point. B, the bridge has lots of weakest point. C, the center of the farthest point is where people is where between each support pier. The center of the deck is where people like to dance. See.
Good.
What happens when the piers are very narrow? A, the bridge is weaker. B, the bridge is stronger. C, if a person stands on the middle of the bridge, will it bend down and pop right back up? D, will it stay the same? Jen.
A?
Yeah.
Wonderful.
And here's my two bridges.
Very good. Very good. Everybody clap for Fawaaz. Well done.